So I hope we are live. Good evening, everyone. So people are also joining. Right. Okay. So good evening, everyone. So let's write. People are coming. Sakshi, Ashish, Abhishek, uh, Sharan, Gaurav, Hemant, Komal. Good evening. Very good evening. Namaste. So welcome back to our session. Hi, Hari. So everybody please give one like so that to give the attendance. Those who are in the live, please press like button. Share this information to your friends also. The live started. So we will start in 1-2 minutes the session, original session. Very good evening. I am very fine, Basant. Okay, Navneeta. Good. So people are coming late as usual. I am fine, Prachusha. You are from Kerala. Fine. Where are you from? In Kerala, mine. I've been to Kochi so many times. Last 6 years, every year by this time in August, I'm in Kochi only. I'm fine, assist. So I think okay. Let's start the session. Let's start the session. So last lecture we are discussing about the sources, that is the classification of sources. In the classification of sources, so classification of sources we are discussing. In that I gave two parts, independent and dependent. So what are independent sources? What are dependent sources? Independent sources means they will deliver the energy to the network on its own. On its own does not mean it will create the energy. It will convert some form of energy into electrical form. Last lecture we discussed this part also. Dependent also gives the energy, but by taking from independent. By taking from the independent, dependent will give the energy. Okay, so now in that we have different variations, all those things we discuss one by one. So what is the fundamental difference between independent and dependent? Let's write that point. Independent deliver energy to the network on its own. We are not violating law of conservation of energy. I am again saying, okay, what about dependents are dependent deliver energy by taking from some other independent. It will take the energy from some other independent source and give here. Best example is your transistor, op amp, etc. They can do the amplification, but in the presence of independent source only. In the presence of independent source, it can do the amplification. Okay, so now we move to the different sources like voltage source, current source, everything. So please listen. So the next one we are going to discuss is, first we are discussing independent sources, in that ideal voltage source. Ideal voltage source. We are discussing ideal voltage source. Let me check. When I am from Kakinada. Ritik, already I started a sequential, 2 topics are done, remaining also I will plan like every week some part. Okay, so just wait. I stay at what we call Hyderabad, Abhinav. Capacitor is linear only. Nani? All resistor, inductor, capacitor are example of linear passive bilateral elements only. Okay. So please listen here. Please listen. Let's continue with the topic now. So ideal voltage source. Let's discuss ideal voltage source. Thank you, Vinay. So let's start. Listen here. This is Vs. This is what we call ideal voltage source. Okay, now see here. For this ideal source, suppose I connect. This is I am connecting. It is not part of the source. A load resistance RL. How it will work? Let us see. Because it is parallel, its voltage V is always equal to Vs. And this current is I. Okay. So how to draw the characteristics of this element? How to draw the characteristics of this element? Say this is your voltage V. This V I am plotting with respect to current. Current can be anything. The terminal voltage between these two terminals, say A and B, is always equal to Vs. This is what we call ideal voltage source. In an ideal voltage source, the voltage V is always equal to Vs. Current can be anything. How current varies, sir? Depending on the resistance you connect. Current varies depending on resistance you connect. For example, let's take one example of ideal source of 3 volts. Another case, ideal source of 3 volts. Another case, ideal source of 3 volts. For these 3 cases, let me take the same source is there, but let me connect 3 different loads. Let me connect 3 different loads. Okay. So because it is in parallel, voltage is the same. What is variable? Current is variable. 3 by 3. What is the answer? 1 ampere. Here 3 by 2. 1.5. 3 by 1. 3 amperes. 3 by 1. 3 amperes. So observe here. Current can vary depending on the load you connect. It can give any amount of current, but voltage is always stays constant. This is an example of ideal voltage source. Ideal voltage source is like a ocean. It can give you how much you want, that much it can give, but it will maintain the voltage constant. It will maintain its voltage constant, but current can be any value. Now let us see one question. Mine, I will tell you that. Just few minutes, Hitesh. Okay, it is just polarity, Dilip. Okay, if you take it is a polarity which will decide the voltage plus 3 volts. If I take minus 3 volts, current will be reversed. That is the simple difference. Okay, we discuss KCL, KVL. It will be clear. Don't worry about it much. Now, tell me the answer for this question. Guys, everybody comment. Yes, Kumud, available. So please answer this question. Please answer this question. I am waiting for your solution. Option A, B, C, D. It is one of the IES question. Now, previous IES paper it is given. Now you people are able to solve this question or not. Let us check it. So give your answer. Option A, B, C, D, whatever. Give according to your opinion, whatever the answer. Very good, very good. So everybody please participating in the class. Be active in the class. Good. So most of you are giving the right answers and also wrong answers. Most of you are giving right and wrong mixed answers. But for most of the people, the favorite answer is this is wrong answer. A is wrong answer. What is the right answer here? B. What is the right answer here is B only, not A. A is not the right answer, B is the right answer. Then you will get the doubt. Sir, just now you discussed this, it is the characteristic same figure came. We discuss only positive current here because the load is resistance. We have not discussed anything about negative current. Okay, let me prove the answer is B. Let me prove the answer is B. Wait. So let me prove it. Let me prove it. Just wait. Just wait. Everybody. So let's take one ideal source of your wish. Any voltage. Take your choice. So let me take 10 volts. So here also. 10 volts. So three cases I am taking. All the cases, what is the ideal source? I am having 10 volts. So let me connect here three different loads. Okay. Okay. Three different loads I have connected. Say here 10, 1. This is 1, 10. Let us take 10 only. Here you take some 3 ampere, just for example. So three possible cases I have taken. Now see here, everybody see here. Parallel voltage is same. So what is this current? 10 by 10, 1 ampere. What is this current? 1 ampere. This is 1 ampere, this is 1 ampere. Then what is this current? I? I equal to 2. Current entering should be equal to leaving. First case. Second case, parallel voltage is same. 10 by 10. What is the current? 1 ampere. This current is also 1 ampere. One is entering, one is leaving. Then what is this current? According to KCL, 0. Thank you, Kumut. So similarly here, what you are having? 10. 10 by 10, what is the answer? 1 ampere. This is 3 amperes. So 3 comes, 1 is leaving, the left will go here, that is 2 ampere. We discussed that KCL, okay, later. So what is the current I according to the same direction as earlier case is now -2. Now the current is -2. From these three figures, what we can conclude? What we can conclude, current can be a positive value depending on the load you connect. It can be 0, it can be negative also. It can be positive, it can be negative, it can be 0 also. Depending on the load you have connected, current can be any value in the ideal source. So voltage source ka current direction or magnitude is not fixed. It purely depends on the network you have connected. It purely depends on the network we have connected. What happened? Voice is not clear, Ramesh. Remaining students, please tell me voice is clear or not. Please comment. Am I audible to you? Increase the volume. Mic is. It is clear? Okay. Fine. Fine. Okay. So see here. Please listen. Someone have the doubts for some particular network. Suma, please understand. I am not saying that about network. We are speaking about source. We are speaking about the ideal voltage source. For ideal voltage source, current can be positive quantity, current can be 0, current can be negative quantity also. Okay, so listen here. You can take like this. So voltage is always constant. Current can be positive, current can be negative, but the voltage V is always equal to Vs. V is always equal to Vs. V is always equal to Vs. Current can be a positive or negative. For example, here instead of this, if I connect 1 ohm resistor, it can give 8 amperes. So if it is requiring current, it will give you. If it is not requiring, it will not give. If it is having excess, it will take. Okay. It is clearly depending on the load you have connected. So that's why ideal source current is never a fixed quantity. It can be positive, it can be negative, it can be anything. Okay. It is like a washing, I told. Suppose in the washing, you take some bucket of water, it will give. You take a mug, it will give. You add a mug, it will take. But it will remain constant. That is, its voltage remain constant. How much you want, ideally, it can give. This is ideal case. This is ideal case. Okay. So now see here. These characteristics you see, is it linear or non-linear? Is it a straight line passing through horizon? No. Is it a linear or non-linear? Please tell me. Linear or non-linear? Yes, afak. Last case it is absorbing, first case it is delivering. Non-linear. Very good. So it is not linear, it is non-linear. Okay, it is non-linear. Is it active? Yes, it is active because the impedance can be both cases. And also unilateral because the impedance is not same in both the cases. Here this V and I is not positive to negative. It is with respect to negative to positive we plotted. Okay, like yesterday question, yesterday class, one question we have done. So you can say like this. All independent sources are non-linear in nature due to the inherent non-linear relationship between voltage and current. They are basically non-linear, active, unilateral. It is proved here from the characteristics. Okay. So now what is the way to explain ideal voltage sources? These are the points. Please see. The terminal voltage offered by ideal voltage source, whatever the terminal voltage offered by the ideal voltage source is independent of current flowing through it. Current can be plus 2, minus 2, 0, 20, 200, any value, voltage is same. Voltage is always same. Okay. Next, what is that? The current through the ideal voltage source can be positive, it can be negative, it can be any value, purely depending on the remaining part of the network. That is, it is a unknown quantity. This is a unknown quantity. It can be any value. It is a unknown quantity. It can be any value purely depending on the network you have connected. Is it clear up to this? Shall we move further? Okay, let's move further. Very good, very good. Next, if you see, ideal case is not possible. Practically what happens in any source, with increase in the load current, internal losses will also increase. That loss will decrease the terminal voltage across the network. The loss will decrease the terminal voltage across the elements. What is the disadvantage here? With the increase in the current, the voltage will be decreased and the loss will be represented. That loss will increase with increase in the current. So how to represent that loss? Let us see. How to represent that loss? So that can be done with the help of the next case called practical voltage source. That is a practical voltage source. Let's do it. So ideal source is like this. We have taken DC for making the analysis easy. We discussed the AC also later. That loss can be represented with the help of resistance which is in series with the source. This resistance is called internal resistance of the source. What is this resistance? It is called internal resistance of the source. Please understand, resistance offered by the source, internal resistance, both not same. Resistance offered by the source is its voltage current ratio. Internal resistance is this one. That loss we represent with the help of internal resistance in series. Now let us see here. If you connect some external load like this, that is RL. If you connect some external load like this, that is RL. Thank you. Now what happens? how this voltage V, varies. Earlier this V is a constant, whatever may be the load. But now how this V is going to change? Let's do the analysis. Say assume this is your current. Any passive element, how to take polarities? Current enters from positive, leaves from negative. That is I into Rs. Let's apply KVL. Let us apply KVL. We have not discussed KCL, KVL. I know it. Just for continuity, if you apply the loop equation to this loop, it will come out to be Vs minus I Rs minus V equal to 0. What is V? It is Vs minus IRS. Vs minus IRS. If current is increased, this negative part will increase, the overall drop will decrease. If the current increases, the negative part will increase and the overall voltage available for us will decrease. Let us show that. Suppose you take this is your voltage with respect to current I. See here. So this is a constant line called Vs. Everybody careful. Now it is if I0, this is Vs only. If I increases, it will decrease Vs minus IRS. So what is the response you will be getting? This is the response you will be getting. What is this response? Vs minus IRS. With increase in the current, the terminal voltage available will decrease. This is what we call practical voltage source. Why we represented this resistance in series only? Why not in parallel? Can be question to some people. For some students, they can have this, that is RS can be parallel also, na? Sir, why you take in series only? If you take it in parallel, voltage is always constant. It will not represent the loss with current. To represent the loss, we take it in series only. Okay? Good. Yes, Pratyusha, I will come to that point. For ideal source, what is the internal resistance? We will come to that after current source discussion. I will give one example for better understanding of this. Let's discuss that part also. Yesterday notes I have uploaded in the group just 1 hour before. Nagendra, please check. Okay. Can V become 0? Okay. Yes, definitely it can become 0. When you short circuit, it will become 0. Okay. So let's move further. Okay. Listen here. Let's take one example. You have a source of, let's take for example, you have a 3 volt source with internal resistance of 1 ohm. This is the source I am having. Just assume. I said Abhishek already, you attended all the classes or not, I don't know. First class I told that sources will not satisfy Ohm's law. Sources will not satisfy Ohm's law because they are non-linear. For non-linear, R is not constant. So let's take, okay, if you take Amit, if you take the resistance in shunt, That will not represent the decrease in the resistance practically. If you take resistance in shunt, voltage is always the same because they are in parallel. So you will get again ideal case only. Okay. So now see here. Now see here. Remaining. Please listen here. Please listen here. Let us connect. Let us connect three different loads here. So 3, 2, 1. So what is this voltage? Let us calculate this in all the three cases. So here, what is the current? 3 by total resistance is how much? 4, which is 0.75. Here, 3 by total resistance is how much? 3. You understand? V by total resistance, 1. Here, 3 by 2, 1.5 amperes. Now, what is the drop here? If it is 0.75 into 3, it will give you 2.25. This will give you 1 into 2. This will give you 1.5 into 1. So now you observe here. What is this? 2.25. 2.25. 1 minute. Yes. Here it is 2.25. Here it is 2. Here it is 1.5. With the increase in the current from 0.75, 1, 1.5, your voltage decreases to 2.25, 2 and 1.5. What is the meaning of it? With the increase in the current, there is a decrease in the voltage. With the increase in the current, there is a decrease in the voltage. So practically, your voltage available is not a constant. It is dependent on the current flowing through it. It is not independent of current flowing through it. You understand the logic now? See, if the Telegram group is not working, just message me. I have given my number already. I will add you. Those who have given message me yesterday, I have added all of them in the groups. Karthik Reddy, just wait. When we discuss the series and parallel connection, there I will discuss voltage division and current division. Now I am not discussing that. Okay. So simply I made it current into resistance. You can apply that definitely. Okay. So is it clear now? So practically you can see this. How to see this, sir? Practically, I will explain. For example, you have a car or bike. Whenever you start your bike or car, suppose your headlight is in on condition. Your light is in on condition. You have started your vehicle. So you can observe whenever you start during that period, this brightness will decrease. Have you observed this practically or not? Your headlight is in on condition, you switch on your vehicle, you just start your vehicle. So why? Because during the ignition your vehicle requires more current. I mean the battery draws more current. For ignition huge amount of current is required. When current is increased, this voltage will decrease, the brightness of the bulb will decrease. After some time the startup is completed, current goes to normal level, voltage goes to normal level, the brightness can be in the normal level. Yes, Navneet. Abhishek, what is, sir? Can R change by voltage or current? R can change. R is V by I. If any one of them is constant, if other is variable, R is also variable. Just follow the first classes. If you have not attended, please go through them, Abhinay. You will get the clarity. Very good. Let's move. Let's move to the next. So that is about your practical source. So these are the points to note from the practical source. One more thing. Listen here. What is the equation of the practical source? I got it. V is equal to Vs minus IRS. If I make I equal to 0, what is my V? Please tell me. If I make this current equal to 0, V will be equal to Vs. V will be equal to Vs. So let's do this. Let's do this. How to make current 0? How to make current 0? Everybody please tell me. Good evening, Shalini. Tell me how to make current 0, open circuit. How to make voltage 0? Voltage 0, short circuit. Okay, very good, very good, very good. So now take the equation, make the current 0. That is, take the same figure. What is that figure? This figure. Make this current equal to 0. So let me take that figure. Let me take that figure. That is RS. What is this current? I equal to 0. Then according to the analysis we got it, you will get V equal to Vs. This will give you an important analysis like you have a resistor. That resistor is having a resistance of Rs. This current is 0. Voltage here and voltage here will be same. That is, whenever current through any passive element is 0, you can say the potential difference is 0. Because if current 0, the potential difference must be 0. Because for current flow, what is the required condition? Potential difference. So here I have 1000 volts, 1 kV is there. Here also I have 1 kV. In between I connect a wire, no current will flow. Okay, but you have here only 1 volt, but here you have 0.5. Difference is there, current will flow. So both the ends you have same voltage, even it is high voltage, it will not be giving you any current. So current purely depends on what? The potential difference between the 2 points. Okay. So let's move to the problem. So these are the points you can note for the practical voltage source. The terminal voltage offered by the practical voltage source is dependent on the current. It is not independent like previous case. Voltage depends on the current. According to the current, loss increase, voltage decrease. Next point. Whenever current through the passive element is 0, this point. Current through the passive element is 0. Then voltage at both the ends must be same and vice versa. That is, whenever current is 0, voltage here should be same and vice versa. So now let's move to the next part. Let's start doing the problems. Based on the discussion we have done, let's do this question. Okay, before doing the question, are you guys ready? Are you comfortable up to this? Are you comfortable up to this? Be interactive in the class so that you don't feel the monotony. Be interactive in the class. Okay. I will almost I watch every single comment as much as possible. Sometimes it may not be possible. Don't worry about it, but keep commenting. For the source X, you have the point 4, 0, which means my voltage is 4, current is 0. Current 0 means open circuit. Okay. Next, another is there 0, 2. What does it mean? Current is 0. Sorry. Let's do this first. So let's take one practical source because examiner has given it as a practical source. It is Vs1. You will be getting is same as the other voltage, that is Vs. Whenever the current through any passive element is 0, voltage at both the ends must be same. Whenever the current through any passive element is 0, voltage at both the ends must be same. That's why this voltage is equal to Vs. This voltage is equal to Vs. Now you tell me, listen here. You got one information. What is the second information? I'm sorry. Your 0 comma 2, that is voltage is 0 but current is 2. How you get voltage 0, man? Short circuit. How do you get voltage 0? Short circuit. So take this same network Vs1, Rs1, short circuit. If you short circuit this, the current I is equal to Vs1 by Rs1, which is equal to 4 by, as per our analysis, it is 2. But you know, what is Rs1? Vs1 by 2. That is 4 by 2. You got this information. Now go back. How I told earlier directly, simple rule. What is this? This is the voltage when current equal to 0. It is nothing but Vs1. Similarly, what is this voltage? Directly you can say it is Vs2. Directly you can say it is Vs2. Similarly, this is the current. What is this current is given by ratio of V by R from this analysis. What is this current? It is ratio of V by R. That is the voltage 0. Whatever the current you get is V by R. So using that in your mind, 4 by 2 will give you the resistance. Similarly, what is the resistance you get? Rs2. How to get Rs2 value? 3 by 3. This is the blind or easiest way to do this problem is, instead of doing that analysis, make current 0. Whatever you get is Vs. Take these ratios, you get Rs. So similarly, you can say Vs2 will be equal to 3, Rs2 will be equal to 1. You got the answer now. So see here, you have a resistor and a source, X and Y. So for the X it is 4 and 2. For Y it is 3 and 3. 3 and 1. Now for this we have connected a load resistor. For this we have connected a load resistor of 1 ohm. So this 1 is there here. So what is the current I? 4 plus 3, 7 by 2 plus 1 plus 1. That is 7 by 4 amperes. Okay, any method will give you same answer. Any method will give you same answer. Is it clear to everybody? Please comment. Please comment. Is it clear to everybody? Yes. Ready. Very good. So that is how to deal with the practical source. Now I will give you one question which you can do in 1 minute, less than 1 minute. Let's do that question. The next question. Please try this and comment your answer. This you should do in 1 minute. You should fastly do it because using that previous technique directly you should say the answer. No problem, mine. Initially it will be like that only. When I explain, if it is clear for you, that is more than enough. Firoz, if you have any doubt, please ask specifically what is the doubt you are having, which particular point you have any doubt, please tell me. Firoz, anything doubt in this? What is your doubt in this? Yes, Arnav, that is called series. After out of the 1 voltage battery is there for this output, we connect this. Actually, figure also given same way, na examiner. Negative, positive, negative, positive. Firoz is there. Where is that 1 ohm in series? 1 ohm is given by examiner. This 1 ohm is given by examiner. RS2 is 3 by 3. Because of that, it is 1. Okay, this one is given by examiner. Okay, now come to this question. So, how many of you have done this fastly? It is a practical source. Firoz, practical source will have VS and RS. RS will be in series only. Okay, this is practical source. Examiner in the question statement, just 1 minute guys, let me clear him so that you can understand properly. He said, where is he? Yes, you observe here. It is a practical source. You have a practical source. So, you should take voltage source series with a resistance. Okay, now come here. Tell me. Yes, very good. So some people get 1 ampere, some people get minus 1 ampere, but most of you have given right answer. So here don't do the total stuff not required. I will give you I gave already the easiest method. Apply that method only. Go easily. Do easily. Here directly you can say this is Vs because it is the voltage when current is equal to 0. When current equal to 0, whatever you get, that is your Vs only. Then this is the current I at Vs equal to 0. What is this current when V equal to 0? When V equal to 0, whatever the current you get is called Vs by Rs, which is minus 2. Then what is Rs? It is minus 20. You take this Rs is minus 20 by minus 2. I am doing directly because we have done the same model in the previous question. I am repeating, please see. When this current is 0, forget about axis. This is voltage. When current is 0, whatever the voltage you get is called Vs because the current is the same when current is 0, voltage is same. You got Vs. Then second case is what? When current is minus 2, voltage is 0. Voltage 0 means short circuit. What is the current is this by this. This by this is called Vs by Rs. Vs by Rs, how much you got it? Minus 2. Substitute Vs value, we get Rs equal to 10. So what is the equivalent of that particular is? This is minus 20 means polarity is reverse. Somebody asked me earlier, what is the meaning of negative voltage, sir? Negative voltage ka meaning is simple. Its polarity is not same as you assumed. It is reverse. Okay. So Rs is how much? 10. Please ask, even it is a basic doubt, I am very happy to help you. Now, why minus 20? Because examiner gave. You connect here as per question. When 10 ohm is connected, what is the current I? What is the current I? Minus 20 by 10 plus 10, which is minus 1 ampere. That's all. Simple question. Direct one step you will get the answer. Shall we move further? Shall we move further? Very good. Good. Nice. So let's move to the next question. Good. So I want you people to do this again. I want you people to do this so that please listen. Most of the questions I will do, but first I will give you some time so that you can try. Trying is need not give you solution. Okay, commit the mistakes only. If you commit mistake in the exam, you don't repeat that mistake. Commit as many mistakes in the classroom. I will make you to commit the mistakes so that those mistakes will be avoided in the exam hall. Okay. So try this question. Try this question. Let's go back. 1 minute, please. Somebody has some doubt. Who is that? Shivam. Where is that figure B calculation? Simple, Shivam. What is the line voltage? This is current 0. Voltage is -2. In this circuit, if current is 0, whatever the voltage you get is nothing but Vs only. That's why -20 is taken as Vs. First point is clear. Then see here. Okay, here -2 comma 0. That is current is -2, voltage is 0. Voltage 0 means you short circuit this. What is the current you get is Vs by Rs. That is given by examiner as how much? -2. X comma Y. X is I here, Y is V here. So from that you substitute Vs value, you get the Rs value. Okay, guys, tell me the answer. Ready? What is your doubt? Here, don't take minus of minus here as plus. Okay, here negative voltage line and this is positive voltage line. Okay, so negative voltage mein what is your voltage is -20 axis. So tell me what is the resistance, sorry, RS and VS. Give me your options, options. A, B, C, D, options. A, B, C, D. What is the right answer? Some people gave B, some people gave -2. I don't want to type. You just give me A, B, C, D only. Give me A, B, C, D only. Give me A, B, C, D only. Everybody here. Okay, don't be hurry. Some people are commenting their answers. Don't mind. You have your own timeline. Go by your own timeline. Try. Just give it. So slowly we are increasing the load. Please understand that. We just discussed elements, sources. In that also we have not discussed a current source. Only just voltage source that we discussed. And we are doing small problems. Then we next class we discuss what we call current source, the dependent source, KCL, KVL, node analysis, mesh analysis. Like that we increase the load over a period of time. After that your class will contain around 80% only problems. But initially little theory will be more. After that in the class most of the case we will be discussing problems only. So B, C, D like that. So many gave the right answer? No. Everybody here gave wrong answer only. Any right answer? Let us check it. What is the question? What is I and RS? So some people gave right answer, I think. Some people gave right answer. Let us check it. Firstly, tell me what is RS? What is RS? Tell me what is RS? RS value kitna by? Can I say 10 by -5? RS is 10 by -5. It is -2 or can I say the resistance is 10 by 5? It is 2. So -2 is a wrong answer. Here your important observation required is arrow direction. Yesterday, day before yesterday also I have done one question earlier. in the, I think yesterday only we have done one question based on this. Same way here, current is not leaving, current is not load current, current is entering current. You see previous questions, current leaving, this observation is important. Current is leaving given by examiner. Examiner has given current leaving your network, but here he has given current entering. He means me only. So here we have given, I have given it as entering. That's why you get minus also. Don't take the resistance as negative. Okay, be careful. This is the common mistake students will commit. That's why I have taken this into consideration and I have done this. So answer will be, some people have given right answer only. So B. Let me do it. Let me do it. So see here. Can I say this is 10 comma 0 and this is nothing but your Vs? Yes or no? First point is clear. It is voltage 10, current 0. So this is your Vs only. Next, what about this point? It is not 10 0, no? Just wait, just wait. X-axis is 0, y-axis is 10. That is current is 0, voltage is 10. That is your Vs. When current is 0, open circuit voltage is called Vs. Because the current 0, no drop here. Then this point, that is minus 5 comma 0. This is your I and this is your V. Voltage is 0 means short circuit. Voltage is 0 means short circuit. So next, see here. So take that figure. You have Vs. You take Rs. And he has given voltage is 0. Short circuit it. Then this current is Vs by Rs. But examiner I is in this direction. What is I sir? Minus Vs by Rs. Because examiner current is entering here, not leaving here. So, what is that? Substitute your values from the previous, that is Vs. And this current is minus 5. Vs is 10. Okay. This is minus 10 by Rs. What is Rs? Minus 10 by minus 5. It is 2. Now, the question is very simple. If for this particular network of 10 volts and 2 ohms, we have connected a load resistance of, as per examiner, how much? 2. What is the current? 10 by 2 plus 2, that is real. 10 by 2 plus 2, what is that? 2.5. Okay, but the current is here, let me take this as IL. But examiner want this direction current, which will be minus 2.5. Okay, so you understand, because the direction given is reverse, we should take care of it. Is it clear now to everybody? Everyone here? Everybody here, every day, please come on time so that we can discuss more number of things. And be on time to live only. I already told you. Good. Sir, classes are especially solving problem. Thank you, Navneeta. Okay, Aftak, I only made this question to, because some people have this kind of confusion. So to avoid that, I made this. Voltage is not minus 10. Who told voltage is minus 10? Kumari? Voltage is 10 only. Okay. Every day after the class, I am sending the total notes PDF. Okay. Yes, it is Will. I think we'll make it. Don't worry, we can make a new one. Okay. So listen here. Today I want to give you few more regular general points. General points I want to give you. See here. So last lecture I told you how to prepare for networks is prepare our notes plus previous papers. Okay. So when you do the see what are the previous papers you need to do? You should do sorry gate plus ESC. Okay. You should do three branches for networks at least EC, double E, instrumentation. Even you belong to any branch, you should do all of them. For ESC also at least to do objective questions of electronics and telecommunication and electrical. So you want to purchase the book, you can purchase this. If you don't want to purchase, I mean you have some financial constraints or some problem is there. So you try, definitely you will get the PDFs of this all previous papers by some source. So many students are having, okay, so many groups it is having it, PDFs, etc. You can try by any source, but get it. Get it. Okay. As is, I already told in the class, after few classes, after our basics are completed, then only class may 90% we do only problems. Most of the days we complete the total class will be full of problems. So I already told you if you want to take the subscription, this is the code you can use. This is my code, Shankar 10. So for this code, originally your 1 year subscription fees, that is your coaching fees for 1 year is 25K. After taking the discount code, you will get for 22.5. Okay, if it is 2 years, you will get it. Just share this information, share about Unacademy to all maximum your friends. Not only classes, I mean, not only in YouTube, you are also having free classes in Unacademy app also. Download it and see the classes. There are called special classes, all are completely free. Plus subscription is required to attend these regular classes like a coaching. For that, if you are second year or third year, please go for the 2 year subscription, which will give you 27,000. For which you will get around, normally it is 30,000. Normally it is 30,000. You will be getting it for 27,000. So I am giving you regularly. I will be giving you this information so that it will reach to the maximum student. Even for this video, some new students are there. They must be able to know it. Okay. I want to say for mostly every single student, those who don't know about an academy, just give them information. Ask them to download an academy app. They can access so many free courses. So many free courses and paid courses also. Once you take subscription for GATE and ESC, you can attend GATE and ESC classes of any branch from any faculty. Our total team, you can attend all classes of. Okay, so if you don't have financial crisis, if you want to prepare for GATE exam or if you want to excel in engineering subjects, best quality, then take the subscription. Financial constraint is there, you just attend everyday live. I am there for you, I can definitely help for you. If you don't have financial constraint, don't calculate this money and all those things. Learn. Okay, learn. To learn, you spend something. It is the cheapest possible available resource with the best quality. Okay, so this is the group. I think you need some VPN to what we call download it or add this group. Okay, fine. So that's all for today. We can meet tomorrow again. We have some other classes also you can attend. So bye bye. So Rahul, for active element there is no convention of the sign. If it is current source, we fix the current voltage according to deliver or absorb. It can be anything. Similarly, for voltage source, current can be leaving or entering depending on remaining network. Okay, fine. Okay, bye bye.